Download this code and get free GPT-4o from codegive.com, link in the description below. ### breadth first search, BFS, in Java using queue. Introduction *. Breadth first search, BFS, is an algorithm for traversing or searching tree or graph data structures. It starts at a given node, often referred to as the root in trees, and explores all of its neighbor nodes at the present depth before moving on to nodes at the next depth level. BFS is particularly useful for finding the shortest path on unweighted graphs. Key concepts * 1. Queue. BFS uses a queue data structure to keep track of the nodes that need to be explored. 2. Visited nodes. To prevent processing a node more than once, we maintain a set or a boolean array of visited nodes. Implementation steps * 1. Start by enqueuing the initial node and marking it as visited. 2. While the queue is not empty, dequeue a node from the front of the queue. Process the node, example print its value. Enqueue all unvisited neighbors of the node and mark them as visited. #### code example. Here's a Java implementation of BFS on an indirect graph represented using an adjacency list. #### explanation of the code. 1. Graph class represents a graph using an adjacency list. Vertices, number of vertices in the graph. Adjective list, an array of linked lists to hold the graph's edges. 2. Add edge method adds an edge between two vertices, V and W. 3. BFS method implements the BFS algorithm. It initializes a visited array to track which nodes have been processed. A queue integer is used to hold nodes for processing. The method starts from the specified node, marking it as visited and adding it to the queue. While the queue is not empty, it dequeues a node, processes it, prints it, and enqueues its unvisited neighbors. 4. Main method creates a graph, adds edges, and initiates BFS starting from node 0. #### conclusion. The BFS algorithm efficiently explores nodes level by level using a queue. This implementation can be extended to various applications, such as finding the shortest path in unweighted graphs, solving puzzles, and more. Understanding BFS is fundamental for grasping more advanced graph algorithms.